Good day, students. It's good to have this fourth class with you. It's quite unfortunate that I won't be with you in person, so I see it's very important to use this method to um, record the class and so that you can have access to the course content, despite the fact that I have a busy schedule. So today we going to be talking about networking and communication technologies. Last week we talked about computer devices, input devices, output devices, and peripherals, and we explored different types that we have and how we can classify any device we find and into these various categories. And we learned a lot about how a lot of things happens behind the scene. We learned a bit about cloud technology as well, and it was a very interesting class. I hope this one will also be a very informative one. So today, talking about networking, as usual, I would like to relate our topic today to something spiritual. Um, Thinking about networking, what comes to mind is prayer, and because prayer is a means whereby we, as sons and daughters of God, communicate with our Father in heaven, and without that, it would have been that we'll be lost forever because there won't be a link between us and Him. That shows the importance of communication. And likewise, when it comes to the field of computer, communication is very important. In fact, communication is the basis of what we have today as the internet, and it has really changed the way we live because it has contributed to our life in such a way that we can never really anticipate, even in the past, and we don't know what is yet to come as well because the field of technology keeps advancing at an exponential rate. So, talking about networking and communication, networking simply is about connecting two things together. Human being network, and there are a lot of other areas where networking is done. But in this context, we're talking about networking of computers and how they communicate with one another. And a bit of introduction to that. Networking is the practice of connecting computers and devices to share resources, exchange data, and communicate with one another. When it comes to, I would like to break down that definition. Share resources. What type of resources does computers share? Resources such as files and folder. It could be printer. It could be a web page. It could be a database. It could be a lot of many things that you could ever think of that is stored on one computer can be accessed on another as long as they are networked, as long as it's shared and maybe the appropriate permission is granted. So exchange data, like that's why you can copy something from computer A to computer B, and you can as well maybe delete things even while we are not there, maybe over the internet probably. And you can even copy something over the internet to maybe a computer that resides on another continent entirely, other than the one that we live. So it's something that it goes beyond just networking to computers. It's something more like it's global in nature now, depending on how you want to see it. So, and it also talks about communicate with one another, just like I said before. Computer communicates with one another. Like, okay, for example, you log in on a computer, you want to search something on Google search, and you enter the URL, and before you know it, you hit enter, and then you see the result of your of the address you imputed or the search the result of whatever you entered. That's actually something that your computer actually communicated with another computer, and the computer that I communicated with delivered those things to your computer, and that's why you can have it. It's not by magic, it's the way it works. And it enables collaboration, information sharing, and remote access to resources. Talking about remote access, technology has really advanced to the level that you can even take control of another computer even across the continent. I can control a computer that resides in the US from here, Nigeria, and without having to be there physically. I can control the keyboard and the mouse. I can delete files. I can even copy files from it to my local computer here. There are a lot of things that can be done. So, also one other thing they do is to make an essential component of modern computing infrastructure. So, let's just quickly look at the key points when it comes to networking. Some of the things that we may come across in our day-to-day activities and life as somebody that's using computer. One thing that you will come across when it comes to networking is LAN. You may come across it often. A lot of people may not really understand what LAN is. LAN is actually local area network, and it's typically a simple network, probably a network of two computers, or like basically as I am talking to you, I have a LAN just in this office. I have my Wi-Fi, I have my laptop, I have my phone connected to the Wi-Fi, and it's connecting me to the internet. And that's a LAN. Actually, it's extended because it's now connected to the internet. But I can communicate within my phone, from my phone to my laptop, using the connection that the device, so maybe acting as a form of a switch, connects both of them together. So those are some of the things that can be accomplished. Even some of us, we just think of it, you just get your phone and you want to do something, and you connect your laptop to the hotspot. What you just did, you just set up a network between your phone and your computer, and you eventually set up to connect to the internet. You've just done something that's not ordinary, let me put it that way. So that's how easy it can be, and it can also be complex. It could even get to the level that it may require a seasoned professional to actually set up complex infrastructure and to achieve specific tasks. So that's all about local area. That's like the smallest network you can ever have. It can even be large in some cases, but most of the time it's usually within a specified or a small scope, So maybe in a company, maybe one branch of a company, mostly what you get there is a LAN, and maybe you may have a lot of them computers connected together, maybe from different floors and everything. So it can also be a small one, just like I've explained earlier on. This is a diagram of, a pictorial representation of what it may look like: a hub or a switch connected maybe to a server or to a client or a laptop or a desktop, and and these all computers can communicate because of this linking device. Last week we talked about communication devices. This is one of the communication devices. We will talk about the hub, we talk about the switch, we talk about the router. Basically, those are the three major ones that you're going to come across. And this is like what a hub does. It connects two or more computers. Likewise, a switch. So when we get to that, I'll explain more about that. And now, we're talking about the wide area network, which is a WAN. It's just multiple LAN connected together. So a bigger one, a maybe more complicated version. For example, an example I added to the course notes is you can think of it as maybe you have three companies, and maybe one is in Lagos, one is Port Harcourt, maybe one is in Ile-Ife, and they all have their different lands. But somebody in Port Harcourt needs to generate a report based on something that somebody in Lagos or Ile-Ife has actually done. That means the three offices has to be connected. So connecting the three offices now, which are on different network, actually has made up a wider network, which is called a wide area network. So it could be as small as that, it could even be as more complex. So it can range, and sometimes it may be difficult to actually, get different between the LAN and the WAN because of some specific reasons. So in simple terms, I just want to be very simple. When you think about a very small network, you think about a LAN. When you think about maybe a network that actually maybe span across different geographical area, I think you think about a WAN. And when it comes to metropolitan area network, which is MAN, it's more of classified based on geographical area, maybe a city that has their own networks, so that makes up a metropolitan area network. So that's actually, so the concept still remain the same. They all have some things in common. They are all different types of connection of our computers. And now let's talk about the networking devices. Just like I said before, we're going to talk about three basic networking devices. The first one we're going to talk about is the router. A router is a device that connects two networks together. For example, just like I said, when you have maybe three branches of a company, maybe in three geographical area, maybe the system administration in building 1 or branch 1 has set up the computer there, built the network, and maybe there's another system administrator for network 2 or the second branch, and was already done that. So now they need to connect those networks together. Funny enough, computers that are on different networks may not be able to communicate because they're going to reside on a different, they can't communicate across the network. So there's something that needs to solve that problem. That means you need to find a way of connecting those different networks together to one, so that they can maybe find something like an intermediary that takes requests from network A, looks at it, okay, this is going to network C, it sends it to network C, and once it gets to network C, it's processed. I would like to break it down further. What a router basically does is just like its name implies, it routes traffic. So like now, talking about network A and network B. Network A, okay, sends a file, and it address the network, the file to maybe a computer on network B. Okay, let's do it this way. Network A is A, network B is B, and network C is C. And each computer on network A maybe is named in this way, maybe A1, A2, A3. And let's assume that the same applies for network B and C. Okay, now, maybe computer A1 wants to send something to computer B2. It means it's on a different network. So it addresses the packet or the file or whatever it wants to send to B2. Because B2 is not on network A, there's a default instruction that, okay, anything that is sent on this network or network A that does not belong to network A, okay, it has to go through this route. So the router understands that, okay, anything that does not reside on network A has to go through the router, and the router takes care of it. So the router received the file addressed to B2, looks at it, sees the person that sent it, okay, A1 sent it. Okay, you know what? It's going to remove the address of A1 that sent it, put his own address and replace it as the sender, then sends it to B2. Because the router, what it does is it can be a member of the three networks. So it sounds like maybe an intermediary, like between the three networks. So it can kind of act as a member of the three different networks. So it can remove the address of A1, replace it with its own, let's just say R1, and then it sends it to B2. Then B2 is done with the file and maybe has done what he has, sends it to R1 again, and R1 says that okay, it's that same file that was sent earlier on. Okay, because now it's sent to me because I replaced the address initially. Now that I've also recorded it somewhere, then I'll remove my name as a recipient, then insert A1 as a recipient again, then forward it to A1. That's simply what, in simple terms, a router does. It routes packets. It kind of impersonates along the line, serves, replaces the recipient, and moves it forward because it knows where the file needs to be channeled to. So, and once, because the computer A1 will never know that it did not send the file to B2 directly. You think it's actually to B2, but because it's not on the network, it just sent it to the default route, where if you can't find something on this, you just send it through it here, and router picks it up and does the whole work and returns it. So it's just that easy. So that's what simply a router does in simple terms. So now let's talk about the switch. The switch connects computer in a network. It doesn't do the work of a router by maybe moving things across network. It's actually to connect things within a network. And what it does is it's a bit more advanced than a hub. A hub is more of a mere electronic device that maybe work on principle of just electricity with no complex electronics attached to it. So I think I would explain that of hub first, so that will help us understand why a switch is better. So when it comes to the issue of a hub, the hub also does what the switch does. It connects computer in the network together. However, it's not as sophisticated as a switch. What a hub does is just that, okay, it receives the file. So okay, because it works on one network. Let's say there are three computers. A1 on network A, we have A1, we have A2, we have A3, and A1 wants to send something to A3. It sends it to the switch because that's the only means of communication, and the hub received the information and it just broadcast it to A2 and A3. Then A2 received the information, was like, no, this is not meant for me, it drops it. And A3 received the information, said, okay, this is meant for me, then it accepts it. So that's actually the principle how a hub works. So because of that, because it can't actually identify the destination, it makes the traffic so congested. There are a lot of maybe collisions and and unnecessary traffic moving around on the network. But in the case of a switch, it's more intelligent than a hub in the sense that it can actually read the file. That okay, you send in this file to A3, okay, it will only send it to A3 instead of sending it directly to everybody else on the network. So it reads it and it sends it directly to. So in that case, at the same time, maybe A1 is sending to A3, A2 may be sending to A1 too. So it's kind of separate the channels and read each file and direct straight to where it's meant for. So that's actually what a switch does, which is more, but it's better than what a hub does. So if you are asked that, okay, which is better to connect devices on a network, I think you don't have to think about it before you think about a switch, because it's more advanced than a hub in every way. So that's it. So now we talk about modem. A modem is actually from the words modulation and demodulation. So modulation and demodulation actually means to convert analog signal to digital and vice versa. So that's actually what it does. So that's what it does. And back in the days when we have maybe PSTN, public phone, telephone network, and the rest of it. So you have to have a modem connect to the telephone wire, and then it converts it and makes it digital. Then your computer can understand it and the rest like that. And nowadays that's not actually used, but it's also used in different other applications, not telephone line this time around. So you can use modem for maybe to receive digital signals and rest like that, which are not digital it's not digital signals. It's actually analog signal, maybe in form of waves and the rest of it. Then you can use a modem to actually convert to digital signal that some digital devices can actually understand. So now moving on to communication protocols. Simply speaking, a protocol is just a rule, is a convention that some people decided that okay, for example, Dell, a computer manufacturer, and there's another one, HP. Okay, we can now, instead of you making your computer in such a way that it can't work with HP, or it can't work with maybe Toshiba, why can't we all sit down and say, okay, or there's an independent organization that actually said, okay, so this should be the basic rule that every computer should follow. So when Dell produces a computer, it follows that same rule. If HP produces a computer, it follows that rule. So it actually gives room for interoperability of, even despite the fact that these things were done by different manufacturers. So that's actually why we need protocols. It's a set guideline that everyone follows. If you don't follow the protocol, then maybe you have to be using your computer alone because it doesn't work with others. So, and I don't think any manufacturer will want to do that, except for some very serious reasons. So now, talking about protocol, there are a lot of protocols. It's a lot. But a few of them is just what I would like to point out. We have the TCP/IP, Transmission Control Protocol, and Internet Protocol. I think a lot of us may be familiar with Internet Protocol because, we talk about IP address, and, this time around, we're going to learn more about that. So TCP/IP, TCP from the word, it's actually a protocol, a transport layer protocol, and IP is a network layer protocol. So what it does actually, it's a suite. It's like they are packaged together. That's why it's called a suite. So there are different protocols but packaged together to work together. So one thing that TCP does is actually it's a form of transport layer protocol that when it sends something, it verifies that that thing has been acknowledged, received, before it actually knows that it's received. So it's actually used for communications that you can't afford to miss a portion of it. On the other hand, there are other like UDP. UDP, User Datagram Protocol, is like it's maybe let me just say a colleague to TCP, but it does not seek for acknowledgement. Once you send it, it forgets about it, and it sends the other one. If you like, you send 10 and maybe 5 gets to the destination, it doesn't care. But TCP cares. So if you have a boyfriend that cares, it's acting like TCP. So okay, so TCP actually cares. So it sends and it acknowledges that it makes sure that it acknowledges the receipt of whatever it sends. And if it doesn't acknowledge or get any response, it resends it to be sure that it actually, until it gets an acknowledgement, this has been received. So that's what TCP does. And internet protocol, just like it's associated with our IP address, how computer communicate on, we call it layer 3. So, and Ethernet, it's more of the data and link and physical layer. And on that Ethernet layer, we talk more about maybe the different shapes and sizes of different hardware and the rest of it. And also we talk about the MAC address, yes, on data link layer. That's actually the physical address. When somebody tells you a physical address, it's actually the MAC address, media access control. So it's also in hexadecimal in base 16. So it's a string of numbers as well, just like IP address. But IP address is not in base 16. It's actually represented decimal, but actually the computer sees it as binary. Likewise, the one that's also represented as hexadecimal as well is also seen as computer as binary at the end of the day. So everything the computer understands is binary. So whatever you do, still we have to be resolved to binary before anything has to be done on it. So now we talk about the wireless fidelity, which is we all know as Wi-Fi. We know about the hypertext transfer protocol, which we know as the HTTP. And we also have the secure version of it, which is the HTTPS. Many of us don't really know what these things does. It's actually the one that takes care of what you do online. You order like maybe www.whatever.com, and it goes and it loads the page. Everything that's done is using that protocol. It's an application layer protocol. It's in charge of how the message is organized, the structure it takes, how it receives it, how it represents it, and the rest of it on the application layer. So that's actually what we see when we're in our browser. Sometimes we see a padlock, which shows that it's HTTPS. It's secure version of HTTP. And just like we can see, this is an example. We can see that it's written https://w.pngwing.com. So this shows that the connection is a secured connection, a secured version of HTTP. So that means this connection, if somebody finds a way to tap it in the middle, it's going to be difficult for the person to understand what it means because it's secured, it has been encrypted. So it actually can be decrypted based on certain processes, which most times cannot be done on the recipient's computer because of maybe the keys and everything that has been in place on the computer. So those are some of the things that is involved when it comes to HTTP and HTTPS. So now let's talk about the different types of network connections. This is quite simple. We all know wired connections. The wired connection require physical cables. It could be in form of maybe Ethernet cable. It could be even fiber optic cables. It could be quasar cable. It could be in any form. As long as it's physical cables, it's wired. But nowadays, most of the things we use doesn't require wire, like our phones. We just walk in somewhere, we connect to the internet. We don't have to carry wire and connect to our phone and go and look for somewhere to plug it to on maybe on a switch or in a router or something. How does that happen? That's because of the technology that has also been developed to kind of replace or maybe coexist with the wired, and it's built on radio waves, electromagnetic waves, and based on certain standard as well. So it's transmitted in the air and it's transmitted by the transmitter and received by the receivers. So most of the time your phone have the transmitter and receiver. That's why you can call and receive call. That's why you can connect to the Wi-Fi access points and like nothing happened, and you connect to the internet without having to plug a cable and the rest of like. And it has extended to a lot of other things. It has helped us to be more flexible. It has provided flexibility, mobility, scalability. Easily you can maybe connect like 10 phones to a hotspot, and without having to do the hectic work of maybe connecting cable, looking for adapter or something, or it's done like seamlessly. So that's one of the beauty of the wireless technology. So now we can also when we talk about wireless, we also talk about the IoT devices. The IoT means Internet of Things, and maybe electronic door lock, maybe wireless light switch, and a lot of things. Maybe you can even a way of maybe controlling the temperature in your room before you even get home using the internet, maybe via your phone, and maybe switching off your lights while you're at work because you have control over everything at home. Or maybe you forgot to turn off your freezer, and maybe your power outlet for the freezer is smart, and you can just press some buttons on your phone and it switch off because it's connected to the internet, and you can give it command from wherever you are without having to be at home. So those are some of the things that we talk about when it comes to Internet of Things. And now, coming to network technologies and standards, there are a lot of technologies. We're going to just scratch the surface in this course because it's more of an introductory course. So we talked about the Ethernet before, and the Ethernet is actually used, is a network that defines the physical and data link layer, just like I said before. And these layers we're talking about, they are not physical layers. They are layers in a particular standard that some people have set. It's called the OSI model. So starting from the lower one, which is physical model, and that's how the computer works its way to the application layer at the topmost. And for example, okay, you send something to the computer, it goes as a normal signal, maybe a signal of 5 volts, 10 volts, or whatever, maybe in different intervals, and the computer receives that signals and decodes it, it to become a frame, and then it's processed again from that layer, which is the data link layer. It turns into a packet, which now you can identify that, okay, this is what it actually means and everything. Then gradually like that, until it presents it to you on your screen as a web page. That's actually, then the same thing happens. That's when I receive it. What if I'm sending it? So I'm maybe type something on my web page, and the instruction is sent to the computer, and the computer breaks it down gradually until it turns it to a group of 1 and 0. And that 1 and 0 is transmitted over the wire or maybe over radio waves as signals that another computer received on the physical layer and goes through the data link layer, and then eventually appears on the screen on maybe in the browser as a result of the application layer protocol. So that's actually how it works. So now, talking about the Ethernet, it's based on the 802.3 standard. These are standards. This IEEE standard, IEEE stands for I think International Electrical Electronics Engineer, and these are some of the standards that they've set for wireless communication, wired communication, and every different types of communication. So any communication that works within the standard, that is within a standard, needs to stick to the rules of that standard to be able to be generally accepted. So that's actually what it means. And on that data link layer, there's a means of identifying devices. It's called the MAC address. It's different from the IP address. It's more of bonds, mostly bonds onto the device. Like if you buy maybe a computer now and you connect to the Wi-Fi, it has a bond, it's like a permanent MAC address on the network card. However, there are ways to change it, but there's usually a bond MAC address on every device, even your phone and other devices like that. So now, if you connect to my Wi-Fi and don't like your face, I can easily look for your MAC address. Even if I don't know your IP address, I can just block that MAC address, and you will just try from today to eternity, and you can't connect, because I've been able to identify you with your MAC address, and I've blacklisted you on my network. So that's actually a way of identifying on the data link layer. So now, when it comes to Wi-Fi, I think we all know what. And that's actually because it's different from Ethernet. It works on a different standard. So we have the IEEE 802.11, and that's the standard that governs wireless communication that falls under the category of Wi-Fi. Though we have different types of it, but they all are within the same standard. They are just different variants in the same standard. So that's actually what, as you can see, I have a sample of a wireless device. It's a wireless router, and that means it can connect two networks together. Maybe one network being the internet and your network at home. So you can send something from your home to the internet, and you can receive something from the internet to your home. So that's actually why it's called a router. And now, this is the official logo of the Wi-Fi. And now, let's talk about one important thing as well, TCP/IP. I think I touched it earlier on, TCP/IP. TCP/IP is used to transfer data over a network, yes, including the internet. It provides reliable end-to-end communication between devices and supports various networking services. So I would like to share something with you. Let's see how TCP/IP works. And when we talk about TCP/IP, it also have a way of identifying a computer on that level. Basically, it's level 3, which is the IP level. So, and that the way you identify a device with that on that level is by its IP address. And we have two versions of IP address. We have the old one, which is still in use, the IP version 4, which may over the time become obsolete as the population of the world grows more than the available space. So hence the need for another better one, which is the IP version 6, and that has been estimated to be very difficult to be filled up, even at the rate which the world is growing in population. So, but still relatively new compared to, and not a lot of people really understand it's complex and compared to the IP version 4. So today we're going to be talking more about the IP version 4 because this is more of an introductory course. So I'm going to share something with you. So let me just quickly share this with you. So I will see how the IP version okay, so the IP works. Okay, now let's check this out. Let's check this out. Okay, come in. Let's get this out of the way. Okay, so now we're talking about IP address. That's the way the computer identifies another computer on the layer 3, which is the network layer, which is identified by IP address. And we are talking about IP version 4. And basically, when I talk about IP in this course, for now, it's going to be talking about IP version 4. We're not going to be touching IP version 6, other than the little details I've shared earlier. So now, IP version 4. How does humans see IP version 4? So this is the IP address, and the IP address is by which the computer, it's the way the computer identify each other. It's a group of 4 numbers separated by dots. So just like we can see, 192.168.233.23 is a group. It's actually a group of numbers separated by dots. So there are 4 numbers separated by 3 dots. So each of those numbers can range from 0 to 255. And why 255? Well, you may need to find out later. Let's find out. So let's now see how a computer sees that same IP address. So now, how a computer sees IP address, exactly how you see it, but there's some differences in the way the computer sees it. Instead of the computer seeing it as a binary, as a decimal number, just like it's kind of easy for us human beings to do things in decimal, but for computer it actually understands binaries. So now this is binary of 192.168.233.23. So now this is the binary. This is how the computer understands it. So it's a group of 8 numbers, usually ones and zeros because it's in binary. It's called an octet. It's separated by dots, and that binary in that octet binary is actually the one that is converted to a decimal that we human beings understand. So it can range from 8 zeros to 8 ones. 8 ones being the maximum and 0 being 8 zeros being the minimum. So now let's move on to the next. So now this is exactly how it is. In decimal, you get 192.168.233.23, and then in binary, this is what you get. This is how different we see things from the way computer sees things. So now, for IP version 4, we have different classes. So we have the class A, class B, class C. We also have the class D and E, but we're not going to be touching the class D and E because they are for special purposes, which is outside the range of what we're going to be discussing today. So now, for class A, it ranges from 0.0.0.0 to 127.255.255.25, and B ranges from 128.0.0.0 to 191.255.255.55. Class C ranges from 192.0.0.0 to 223.255.255.255. So you can easily identify an IP address that falls within each range. Like for example, you have 10.something.something, you know that okay, definitely that was within the range of class A. Or maybe you'll find 172.something.something, you know that definitely is within the range of class B. And maybe you'll see maybe 192.168.something, that's definitely within the range of class C. So that's actually how to quickly get to know which of the classes it falls. However, when it comes to other aspects of networking, it doesn't happen that way all the time. But for the scope of what we are learning today, it's safe to help you understand that okay, that's how it is. There's actually a different way of doing it, that you can disregard the classes and reorganize your things. They call it classless interdomain routing, CIDR. So that's actually different, and it's on a more complex scale than what we are learning today. So let's just accept, let's take it as it is. So now this is the subnet mask. What's the subnet mask? A subnet mask is used by a computer to identify the portion of the IP address that is used to identify the network and the host. So now, just like I talked about network A, network B, network C, and I talked about the computer bearing B1, B2, B3, and A1, A2, A3, and C1, C2, C3. So B actually identify the network, and the 1 or 2 or 3 identify the host. Likewise is the IP address. And just like we as human beings also have physical address, we can have maybe flat 6, floor 10, number so of so street in so town in so state. That's actually, so we can even separate your address into 2. Okay, this portion is the portion of the streets, and this portion is the portion of the block or the building or the flat. Similarly, is also the same that applies to IP version 4 and even IP version 6. So for the computer to know that, okay, this is the portion of that address that is talking about network, that's why we need the subnet mask. You can have two addresses, IP addresses, and they can mean two different things depending on the subnet mask. Because it's the subnet mask that tells the computer that, okay, take the first 8 bits or the first number as the network address and take others as the host address, or take the first 2 as the host network address and the others as the host address. So that's actually how it works. So whenever you see 255.255 in a network, a subnet mask, it's actually the portion of the IP address that is assigned to the network. So the first part of the IP address in a class A network IP address is actually assigned to the network, whereas the last 3 numbers are actually the host address. And when it comes to B, the first 2 numbers is assigned to the network, and the last 2 numbers are assigned to the host. In class C, the first 3 numbers is assigned to the network, whereas the last one is assigned to the host. So that's how it is for network, and this is how it means. So now, just like what I explained, so the 255 underneath shows that, okay, 192 is assigned to the host, to the network. The next 255 shows that, okay, 168 is also a network address, and the next one also shows that, okay, 233 is also a network address. But the 0 says that, okay, that 0 is actually, that's the host address. So every computer on that network bears the same network address, but what changes is the host address depending on the computer. The same thing applies to this. This is a class A address, while this is a class C address. So now the same thing applies to class C address. A class C address is only the first portion of it that's actually assigned to the network, whereas the 3 other portion is assigned to the host. So that's actually where we're going to stop about that for now. So now let's move on to our course notes. I've also included in our course notes already. So now let's move on to DNS. DNS is also something you come across. It's called domain name system. It's an hierarchical naming system. That's why simply what DNS does is actually it converts IP address to human readable names, or the other way around. So you can type in www.google.com in your browser. It's a DNS that does the work of converting to the IP address, and that's the IP address that will be used to search for that server. It can't search it with the bare name. So that's why a DNS is very important. And likewise, the other way around, you can also use the IP address to search for the name. The other way around. All is done by the work of a DNS. So if in a network the DNS is dead, it's not possible for you to actually connect to other computer without having the IP address. You must have the IP address because that's what it understands raw. But if you have a DNS, you can put in a human readable name and it will translate it to an IP address and it gets it back to you. So that's actually what a DNS does. This is kind of a way. So for example, this is a browser now. Okay, I enter www.scalar.com. It sends it to the DNS resolver. After even checking on its own, because it also has a local cache of DNS records, it sends to the DNS server. DNS server checks its own cache. It says that, oh, it's not there, it's a new name. Okay, it sends it to the root server. The root server, that is the dots at the end of your .com. That one sends it that, okay, it's scalar.com. Okay, say, okay, it's .com. It sends it to him that, okay, go, this is the address of the .com server. It sends it to the .com server. It's like, okay, .com, okay, it's Scalar, okay, Scalar is under me, okay, it sends you, okay, this is the IP address of the DNS server that answers to Scalar.com. So it sends it back to the DNS, and the DNS, okay, now go to the Scalar.com. Okay, it gets the IP address of www.scalar.com, then it sends it back to the client. The client now use that IP address to actually get the site that it's looking for. So that's simply how it works. So now let's talk about one important part as well, is the part of the network security and management. This is a very complex topic when it comes to security, but however, we can learn some basic things from it. So let me just read through the introduction. Network security and management practices are essential for protecting sensitive data, ensuring network availability and maintaining optimal performance. Understanding network security principles and management technique is crucial for safeguarding networked environment against cyber threats and vulnerability. So just like we have a lot of data online, there are also people that are specialized in actually getting to it unauthorized when they are not authorized, because it may mean a lot. It can have a great value to whatever they are doing. So that's actually some of the things that we're going to be looking at. Okay, so now just move this out of the way. Okay, so now let's discuss some few things about security. In case you come across it, you may hear about firewall. Firewall is a security device. It actually filters what comes. It's just like the security guard in a company, or maybe in your apartment or something. So it screens whatever comes in. Is it allowed? Is it denied? Or should I allow it enter? Or should I allow it even enter, not come out? Or should I? So depending on the set rules, just like depending on what you tell your gate man, then it doesn't allow the person to come in. So that's actually what the work of a firewall is. So that's it in simple terms. And now we talk about encryption. We've talked about it in our previous class. Encryption is actually a way of secretly sending messages that even if an unauthorized person has access to that message, the person cannot understand it. So that's actually, and we have different types of that. So that's actually could give us an opportunity to even send our messages over a public network, knowing that even if somebody intercepts it, then it's useless to the person, and when it gets back to me, I can decrypt it. So that's actually what encryption is all about. Now we talk about access control. Basically, we talk about three things. There are three ways that access control is maintained. One is by authentication, another is by authorization, and another one is by accounting. Authentication actually means that, okay, when you want to enter somewhere, you show your ID card. The security man verifies that, okay, is the person on the ID card the same picture and the person that is standing before me? Okay, so you can go in. So that's actually authentication. Now, when you now go in, can you go to the first floor? Do you have authority to enter the third floor? Or do you have authority to enter this particular server room? It's actually, that's now the authorization. What can you do now that you have access? What are the things you can do? You can have access and maybe you can only be in the guest room. You can also have access and be able to walk into the CEO's office. So that's actually what is authorization is all about. And now accounting. Accounting is actually keeping record of what goes in and what goes out, when this was done, how it was done, so that you can always, review the processes and see what you can improve on. So those are some of the things that we talk about when we talk about access control. So now, network monitoring. So there are a lot of devices that are used to monitor monitor the network. One of such is SNMP, which is Simple Network Management Protocol. It's used to, we also have packet sniffers, some of it maybe like Wireshark and the rest of it. So we have monitor traffic, and these are actually things that are used to monitor the traffic, to know what comes in, what goes out, and it helps security professionals to be able to do their work effectively. And also, it also helps the bad guys to be able to do their work too, the other way around, depending on who's best, who can do the job better. So that's why we need to safeguard our credentials, whatever we have, especially when it's exposed to the public internet, like to the internet, to the public network. So that's why we need to be more careful about what we share online, where we save our files, who sees it, who sees our password, or where we paste it, so that we won't forget. A lot of things like that. So those are things that actually security entails. So we've come to the end of today's class, and I think it's a wonderful one. I will encourage that if you have any question, you should put it in the WhatsApp group chat, which I have created, or you attach it to the video. I intend of uploading the video to a YouTube channel, which I will provide the link, or because of internet, I may give you the video without uploading it. So you can just deliver your message to the WhatsApp group, which I created earlier. If anyone is not there, if you have a question but you're not there, you can easily ask others. Brad David is a member of that group, so I may give him authority to add you to the group. So next week we're going to be talking about operating systems and software. So we thank you for your time this week. I hope I'll be able to be in class physically next week to take you that. So thank you, and have a good day.